Okay, so when we solve these absolute value equations today, which I said was our learning goal, we have equations that have one variable in them, but they contain absolute value expressions. When we solve them, the ones we solve today are going to have two solutions. Okay? So we're not going to get just one solution for our variable, we're going to have two in the ones that we work with today. So what did you decide? In a game show, when we have those two contestants guessing the price of the DVD player, and they each had their own guess, and they were both exactly $15 off of the actual price of $169. So what was one of the guesses? Chase?
184.
184. Okay, so $184 was one of the guesses. What was the other guess, Riley?
154.
154. Okay, who wants to share with us? I'm going to guess how many of you got these answers. This is what your guess. You say they were. Okay, who wants to share with us how you actually get that? What did you do? You have to do something to actually get those choices. Chase?
I just added 15 to 169. I minus 15 from 169.
Okay, so you added to the 169 and you subtracted from it, and that takes us exactly $15 away from it. Okay, so good. So now, here's how we could represent that situation with an absolute value equation. You eventually have to figure out how to write absolute value equations of your own to represent situations. Okay, so it was easy work to do. Let me complicate it for you a little bit. Let's write an absolute value equation for it now and learn how to solve it. So we could represent that situation with this equation. Why don't you put a box around that so it stands out to you? And notice, on either side of the x minus 169 are these little like sticks. They're little vertical line segments. And we have to make sure we make those very carefully because they could look like ones. They could, they could look like parentheses. They could look like brackets. There's all kinds of things. So we need to make sure they look just like this. They look like vertical line segments. Okay. So when we write that equation, this is what it actually reads. The absolute value of x subtract 169, that is equal to 15. What it really means is what numbers are, this over here, this 15, what numbers are 15 units, just like you did, you added 15, you subtracted 15, which numbers are 15 units of distance from 169. So 169 was the starting place. It was what it really was, the actual price. And then the 15 was units of distance away from that 169. So what does absolute value actually mean? What does absolute value represent? Do you know? If I ask you for the absolute value of something, what am I really asking you for? Get your books over, right? If I'm asking you for the absolute value of something, what am I really asking you for? Did you pass it in your Caleb? Okay, well there are going to be two answers, I'll give you that. So so if I ask you for the absolute value of something other than 0, if I ask you for the absolute value of something other than 0, you better give me two answers. So you write about that. Because why? What is absolute value? What does it represent? Have you ever heard about absolute value before? Apparently not, because you're all giving me that stare. So instead of a no or a yes, I'm getting a. Okay, then here's what absolute value is. And apparently you can't find it in your book. Distance. How far is it from 0? So if I'm asking you for the absolute value of a number, I'm asking you for its distance. How far is it from 0? Now, when we measure distance, we always measure distance in a positive value. Have you ever heard of distance measured with a negative value? So in other words, if, we think of like on a map, if we're going north, you might think, okay, well, we're going in a positive direction. But if we go south, we're going in a negative direction. So if we head south of town, up to somebody who lives out on the Catherine Road, do you say they live a negative 4.5 miles? No, we still just say 4.5 miles to their place, right? So we don't talk about distance as negative ever. That doesn't mean a negative number can't have distance. We're saying distance is not negative. We always think of it in terms of positive numbers. So for any, would you underline this? Non-zero numbers. So for any non-zero absolute value, there are exactly 2 numbers with that absolute value. So as long as we're not talking about 0, that's what non-zero means. As long as we're not talking about 0, there will be 2 numbers that have that absolute value, that distance from 0. So, like right here, we say the absolute value of x is 10. So in other words, it's asking you, what can x be? What can x be? What number can x be that has a distance, that's what this means, distance of 10. So what number can x be in that situation? Chase?
0.
0. So 0 is 10, has a distance of 10 units from itself. Remember, absolute value means distance from 0. So if we put 0 in here, we would be saying that 0 has a distance of 10 from itself. What do you think? You want to scratch that idea? Okay, so I think that's a good idea to scratch that because I think that is, it doesn't have a distance of 10. What numbers do? Any? Like what? Negative 10. Any others? Am I asking this hard of a question? 1? What? I guess I forgot to wear my hearing aids today with my senior citizen costume, huh? 5?
20.
20? 10? Okay, well, I'm going to the number line here. Come with me. We just decided that negative 10, somebody said has a distance of 10 units. Who was that, by the way? Who decided that? Oh, thanks. Thanks, Easton. So is he right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, it is 10 units of distance from 0. Macy, is there another one? Oh, I thought you were raising your hand. 10. Positive 10. 10 units of distance from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Are there any other numbers on that number line that have a distance of 10 units exactly from 10? From 0, I mean? No. So we could, in this situation, say that x could be either of those 2 numbers. It has 2 solutions. Both negative 10 and positive 10 are 10 units of distance away from 0. Okay, well let's solve our absolute value equation that was set up for the game show situation. Let's solve it algebraically instead of like just what you did. You guys added and subtracted and got the answers. We should get the same answers if we solve our absolute value equation here. Step A, these are important. Step A, isolate the absolute value expression. What does isolate mean? Get it alone. It needs to be by itself. So in other words, the absolute value expression is the absolute value bars and anything inside of those. If there's something outside of it, then that means it's not by itself. Okay? So isolate the absolute value expression. It needs to be by itself on one side. B, to eliminate the absolute value bars. In other words, we need to take them away. We need to get rid of them in the equation. We're going to rewrite the equation as 2 cases. We know that as long as it's not 0, there are 2 numbers that always have that distance. And then C, we need to solve both equations, thus we will get 2 solutions. Okay? So let's do this. Step A, isolate the absolute value expression. Is anything on that left side with the absolute value expression? No, it's all by itself already. So we get to skip step A. Let's write that in our notes. Because it's already isolated. You need to follow these steps because that's what's going to help you be successful with it. Now, in step B, we need to get rid of those absolute value bars. In other words, they're going away. So don't be lazy because I'm going to take points away on your work when you start doing the work right away and you don't do step B. Step B says, so here we are, we're going to step B. You will always have to do step B. In step B, you're going to eliminate those absolute value bars and you're going to rewrite the equation as two cases. In other words, what two numbers have a distance of 15? 15 and negative 15. So we're going to take the expression that was inside the absolute value bars. This is what's supposed to have a distance of 15. Well, 15 happens to have a distance of 15, and negative 15 happens to have a distance of 15. So notice there's no more absolute value bars in there. We've eliminated them by setting up our two cases, setting the expression equal to the two numbers that have that distance. And now in step C, we're going to solve. So what would we do first in this one? Add. Okay, what are we going to add? Okay, 169. So we'll add 169 to both sides. And x is now by itself over here. And what's 15 plus 169? You've already done that once today. 184. So there's one solution. And we're going to have another one. What are we going to do again? Add 169, same thing. Oh no, you remember we're without calculators. So if we have a negative 15, we're adding 169 to it. You actually subtract. Take 169 and you subtract 15, and you get. You've already done that today. You get 154. So we get the same things, but we just complicated this up. You're going to an absolute value equation for it. Okay. Now let's go back. So we were really right here. We were already practicing solving absolute value equations. Let's go to the back side now and practice some more. Number 1, absolute value of x equals 6. Step A, do we need to do it? No. Why not? It's already alone. So skip step A. We always have to do step B. Step B says, get rid of those absolute value bars. Set up your two cases. So what would be one of our cases? X equals 6. And what would be our other case? X equals negative 6. The two numbers that have a distance of 6 from 0. 6 and negative 6. Okay? Step C says solve them. Solve it. It's already solved, isn't it? So in step C, we can really just bring them down and say x equals 6 and circle it, and x equals negative 6 and circle it, and say there's our two solutions. We didn't have to do any work. Questions so far? Okay, number 2. We have to do step A?
Yes.
Yeah, we do. That 4 outside of those absolute value bars next to the absolute value bars. Those absolute value bars are not parentheses, but it acts the same way. If we had a number outside parentheses, it would mean which operation? Multiplication. Well, this means multiplication also, but we don't do distributive property. Don't do that, okay? So what we're going to do is we have to do our step A this time. So step A says, get the absolute value expression by itself. Well, we know to undo multiplying by 4, we have to divide by 4, right? So we're going to end up with the absolute value of x equals what? 9, okay? That's just step A, right? Step A. Get the absolute value expression by itself. Step B says, I'm going to move over here. Step B says you're going to ditch the absolute value bars and set up your two cases. So what would one of our cases be? X equals 9. And x equals, what's the other one? Negative 9. And x equals negative 9. Do we have anything to do? No, it's already alone. So we're going to say, guess what? Here's our solutions. going to try and come up with your own funky ways to show how to work for this, and you're going to get the right answer, and you're going to be like, well, I got the right answer, what's the big deal? And I'm going to be like, cool, I'm so happy you got the right answer, I will give you credit for the right answer. But you're not really showing me that you know the process of doing it, so I might have to not reward you for that part. Okay? Number 3, what should we do? Should we do step A? Yes, we have to, don't we? Because this plus 2 is outside of the absolute value of ours. It's outside of it, so we have to do step A. In step A, what do?
Subtract 2.
Okay, we'll subtract 2 from both sides. Okay, and now we have the absolute value of 3x by itself, and we have 6 on the other side. So this is really saying, what could x be that when it's multiplied by 3, the answer you get will have a distance of 6? So we're ready to move on to step B? Yes or no? Okay. So what are the 2 cases? 3x equals 6 and 3x equals negative 6. It's what it's equal to that we're changing to its opposite. Remember, it turns out opposites are really the same distance from 0. And now go ahead and do step C, because you have to do it this time. You can't just circle those answers and say we're done. We actually have to get x alone yet. Okay, now, brain, be careful, because you know what? Here's what's happened every time on this back side. Brain, why do I have to do both of them? Because you know what? I just get the opposite every time. 6 and negative 6, 9 and negative 9, 2 and negative 2. Why even bother doing that other one? Because I'm just going to get the opposite. Is that what happened? Is that what happened on this one? Did we get opposites there? 184, 154? We didn't, did we? So we have to be careful. Don't let our brain go there. Say, oh, I can save myself some work here. I can just put that the other answer is going to be the opposite of this answer. We can't do that. Be careful of that, okay? So anybody have any questions about number 3? Okay. You have to do step A in this one, right? Okay, go ahead and do it. Step A took a little bit. You had 2 things to do, didn't you? So you should end up with, when you're done with step A, the absolute value of x equals 6. So step B, we set up our 2 cases. What are our 2 cases? Pardon? Subtract. Oh, are you back here in step A? I'm ready to move on from right here over to here to step B, where I set up my 2 cases. What are they? X equals 6 and
X equals
negative 6. Remember, notice, every single time in step B, the absolute value bars are no longer there. They are not there anymore. This is where we're ditching them. And you need to ditch them. They need to go away. Okay? Now step C. Is there anything to solve? Is x already alone? X is already alone, isn't it? So I guess it wouldn't be the end of the world if in step B we circled our answers already, but no one wants to see that. You know what? We never get out of which step? B. We never get out of step B. Okay. Anything I can clear up for you before you problems to do, but carefully write down what you are doing. And if you're like, I don't see anything like this in my notes to help me, then where should you look? In your book, in your examples in your book. Where's your book trying to help you out?